Is this loud enough? Yeah, cool. I see somebody tried to kill me already, so we're going to make this one quick. So this talk is going to be about what else is in Go 1.11. The two main points, which are WebAssembly and modules, have already been taken care of, so I'm left with the peanuts. Thank you, Johan. That is what it says there. So these are the sources that I use to gather my information. I'm not going to cover everything because that would take an hour or longer. But if you want to delve into the details, please feel free to go into those. Now, the ports. A few things were dropped, most notably Windows XP and Vista, because to begin with, you shouldn't be using those anymore. They included lots of code to work around issues in those systems. Also, some older versions of OS X and OpenBSD. And some minor additions for some more exotic architectures, which I'm not going to cover directly. Tooling. This is the last release. 1.11 is going to be the last release to support turning off the Go cache. Everybody's been using it for 1.11. It works very well. So there's no point in keeping the support for disabling it. Go test now runs Go vet by default. This might bite a lot of you. But this is on purpose because vet is supposed to not have any false positives, and you should be running it. So again, Go is opinionated. And Go vet now requires its input packages to type check. Again, if you're writing proper Go code, this should be fine. Before, it used to have fallback modes, which were very wonky, so it doesn't do that anymore. And GoDoc is going to lose its command line interface. GoDoc is going to keep on having a web interface, but no longer a command line interface, because you're supposed to use Go space doc, which until now you had both of those commands to do that, which was kind of confusing. Another piece of tooling, which might not affect many of you, but it might affect you if you've written any static analysis tools or any sort of Go tools, is Go/packages. Now, this supersedes a package called Go/loader. And what Go/loader does is it loads Go packages, duh. But it was designed many years ago by Alan Donovan at Google, and it has some kind of fatal design flaws. Obviously, it doesn't support modules because that was a long time ago, so it revolves around packages, not modules. It doesn't support patterns, so you had to handle that yourself before calling Go/loader. Go/packages doesn't implement the logic to load packages itself, at least not all of it. It calls out tools like Go list. And it also, Go/packages also supports build tools like Bazel. And the point in doing this is that right now, if you wrote a Go tool that does, for example, lint something, and then you can use it on your Go packages, right? It supports packages that build with GoPath, with Go build. But Google itself doesn't use Go build to build Go packages. Big revelation. It uses something called Blaze, and then Bazel is the open source version of that. So Google cannot use any of the tools out there on GitHub. Big whoop. So the solution is Go/packages supports both. So it is going to be a higher level solution to Go/loader, and it is going to support both to some degree. And lastly, it supports caching with Go Cache, which is really nice because some tools should become much, much faster. Another piece of tooling that is being improved this time for Go 1.11 is GoFMT. It has a heuristic system to decide whether or not some fields should be aligned, some field values should be aligned. Now, at the top you have what Go 1.10 does, and at the bottom Go 1.11. And what Go 1.10 does is it compares the length of a field name with the previous one, and only with the previous one. So if you had lots of fields of similar short size, and then one that was very long, it would just break. And that was kind of weird. So the new one, what it does, it keeps an average. So then it knows the whole picture. And some other variables in the heuristic were tweaked, but I'm not going to go into details. Something else that is very cool, I can't remember who did this. This is in the GoDoc web interface. So now if you look at GoDoc entries for standard library APIs, it's going to tell you what Go version introduced those. So for example, if your Go project is a library and supports the last two Go versions, you would know that you cannot use this, because if you use this, it's going to break on 1.11, or on 1.10. Debugging is getting a lot better, because I believe this is because in the last what's it called? In the last, when they asked for input to the Go community, like what should the Go team work on, debugging was by far one of the top priorities. So that's what they've been working on. Now it should be much, much easier to use tools like Delph. And I'm not going to go into details because I know you all want to go to the pub. The runtime is getting improved as well. There's no longer a limit to the size of the heap that you can use. Obviously, we're talking about theoretical limits. In practice, nobody knows what the limit is. On macOS, all the system calls that the runtime does now go through a shared library. And the reason is because now it should be easier to support multiple versions of macOS and iOS, as opposed to just hard coding how the kernel works. And now we got onto what I think is the interesting stuff, which is the compiler changes. To me, by far, the most interesting one is a rewrite in the export format. And the export format is how packages are cached. When you build a library and then you reuse that build library, it is on disk as a .a file, right? So it uses a format to save the types, to save the functions that it declares that are compiled. So before, this format was sequential. So if you had to load a package, you had to load the entire thing, even if you only needed one API, like 5% of it. Now it's indexed, so you can only load exactly what you need and nothing else. So it's sort of like lazy loading. And here shows, it might be a little small, but it shows building Juju and Kubelet, which are probably one of the largest Go binaries out there. And it shows that building those from scratch got 20% faster. And you have to keep in mind that if you do incremental builds, most of the time is going to be spent loading the cached packages and linking. So this 20% is probably much, much higher if this is an incremental build. Another silly little thing that was changed is what I showed you guys earlier. Now there's also errors in the Go compiler, just like it does in GoVet and all the other tools. Inlining got slightly better, but not as good as we all would like it to be. There is a flag called -L equals 4. So -L gives it the level of inlining. So I think the default is 1. I think, don't quote me on that. And basically this number says how aggressive should the compiler be at inlining stuff. And Michael might say that I'm wrong on this. So if you do L4, it is very aggressive in inlining. And I believe it also enables mid-stack inlining. But the reason this is not enabled is because many, many programs, especially large ones like the compiler, the binaries get much larger and much slower. So this heuristic needs to be tweaked because it's way too aggressive right now. So it might come in 1.12, but definitely not 1.11, that this is a default. Clearing maps is also much, much faster now. Up until now, if you wanted to clear a map, you either had to actually iterate over all the elements and remove them, which is expensive, or you would just create a new map, and then you would have to allocate and not reuse the space. Now the compiler learned how to detect that pattern, to delete all the elements, and it just does it directly itself with its runtime magic. So you can see here that it's about twice as fast, and that is very nice. Another similar pattern matching thing that it does now is with slices. If you want to add some number of empty elements, zero value elements to a slice, up until now you had to either do this manually or do this the lazy way with a loop. Now, if you do it that way, the compiler optimizes it for you. And for example, the first two benchmarks are if you have to grow the slice, so you have to reallocate it. So in that case, it doesn't have to clear memory twice because it's doing an atomic operation, so it knows exactly what it's doing. And in the last one, it knows that it doesn't have to allocate anything because the capacity is enough to have those elements. So it's much, much faster, even faster. The last bit of compiler information before all of you fall asleep is the proof pass, which I think is the coolest bit. So proving is basically being able to see facts and seeing relations between those facts. As a silly example, suppose that you have if n smaller than 10, you know that n is smaller than 10, obviously. And then if you make a slice of ins of size 20, you know that length of s is going to be 20. So globally, 10 is smaller than 20. That's obvious. So n is smaller than length of s. 10 is smaller than 20. So if you have a piece of code like, let's make a slice of 20 integers, And then if sum n is smaller than 10, access the nth index, the nth element of that slice. So statically, a human can know that this cannot panic. So in theory, the bounce check, the compiler can eliminate this bounce check. And a bounce check is what basically would panic if you go either, if the index is either too high or too low or negative. Is this, oh yeah. What was that noise? Anyway, so actually Michael told me that this doesn't work, so woo, I didn't check this. But apparently the proof pass doesn't work with make operations just yet, but soon, hopefully. And now I'm going to go over some highlights of changes in the standard library, but I'm not going to go into details because, again, pub. So the first one that I think is the one that's going to affect most users is os.user-cache-dir. This is basically just the user's cache directory, which was not possible to get reliably and portably in plain Go without importing a third-party package. There's also a os user go build tag that makes the os user package build without cgo, which was only possible until now by completely disabling cgo, which is a bit nuclear. The time package now supports numeric time zones, which is useful. And no underscore proxy now supports network ranges, sorry, subnetworks, which is very, very useful, especially if you're in corporate environments like me. Woo! And then there's the reverse proxy, which can now be configured to handle errors in multiple ways, as opposed to just doing it its own way. And finally, something that might be a little confusing is the crypto package. Some of the functions now randomly read an extra byte. And the reason is because some people had written tests that depended on how the crypto packages worked. So they were practically locking in internal behavior. So when a new Go release came out and this internal behavior changed, they would be like, oh, Go broke backwards compatibility. So now every single day, backwards compatibility is going to be broken, so they cannot complain anymore. Well, this is actually true. I wasn't making a joke. A couple of other little features that might be useful to you guys. In text templates and HTML templates, you can now assign to variables as opposed to just declaring them, which I think lots of people in the Hugo project wanted. In temp file, you can also tell it where the random characters are going to go. So you can give, for example, extensions to files. And lastly, performance. And not a lot of performance stuff came in this time. I believe Michael worked on some IBM Z stuff, but I don't think any of you use mainframes, so I'm gonna skip that. I believe the port that got the most attention, at least comparatively, is ARM64. So that port should be noticeably faster if you run on ARM machines, such as phones. Math big. Some pieces were rewritten. So for example, I think it was dividing large numbers or something like that is now like it takes 1/100th of the time that it used to because of algorithms and stuff that I don't understand. On Linux, apparently there's a syscall called splice, and you can use that to copy data, to copy bytes between TCP connections without it being as costly. So in a TCP connection, if you do a copy from, it automatically uses that. So for example, a reverse proxy, an HTTP reverse proxy should be faster now if you're streaming lots of data. Whoa. And finally, the read-write mutex can now be profiled much better. And that is good timing because we're almost done. Whoa, it isn't going to the last slide. But the last slide, you can kind of see it. It says thank you. Oh, yeah, there we go. Yeah, see, perfect timing.